Linear sequences, or sometimes you might hear them called arithmetic progressions, are sequences that increase or decrease by the same amount between each term. To express any term in a concise mathematical way, this can be done using the nth term formula. This is a rule that gives you the value of any term in the sequence, normally in the form an plus b, where a and b are numbers to be determined, and then n is the term you want. So for example, if you want the fifth term, you would sub in 5 for n. The sequence that we have here, 3, 7, 11, 15, 19, we know this is a linear sequence, and we need to check the difference between each term. So what I mean by that, to go from 3 to 7, we've added 4. 7 to 11, we've added 4. 11 to 15, we've added 4. 15 to 19, we've added 4. So that tells me a, the number in front of the n, is going to be 4, because that means every time n goes up by 1, an extra 4 is added. That's what we call the common difference. Next, we need to determine b. This is a number that you either add or subtract to find the correct term. We know that the difference between each one is 4, but you'll notice this isn't just the 4 times table, it's just a little bit different. So what you should do is pick one of the terms. I'm just going to pick the first term, because that makes it really easy, because subbing in 1 is relatively straightforward. So I know that it's in the form 4n plus b, and if I sub in 1, 4 lots of 1 plus b, and the first term is 3, so we set that equal to 3. So now I know 4 plus some number b that we're not sure yet is 3. So I've effectively taken away 1, so b must be minus 1. So now we can rewrite the formula and write our nth term. For example, in this case, we're going to have 4n minus 1. This is our nth term. A good practice to get into here is double checking whether this is correct. So pick another term in the sequence that you haven't used to find this formula. For example, I'm going to use this term, which is the fifth term. I know that because it's 1, 2, 3, 4, 5. And if I sub 5 into our nth term, we should hopefully get 19. So 4 lots of 5, take away 1. Well, 4 lots of 5 is 20. Take away 1 indeed gives us 19. Obviously, you can check this with any of the terms. This is just an example. So in summary, you find a common difference, which is the number it goes up or down by each time. And then most sequences, you're going to add or subtract something after that to adjust it a little bit. 4n on its own would just give you the 4 times table, which you can see this isn't. So we had to take away 1 to make sure we got every term correct. Geometric sequences are a little bit trickier because this time, rather than having a common difference, they have what we call a common ratio, which is basically a number that each term gets multiplied by to find the next term. So with that in mind, we know that we're multiplying by something to get to the next term. So let's figure out what we multiplied by here. Let's just do 1.5 divided by 0.5, because obviously working backwards you would divide, and you get 3. So we must have multiplied by 3 here. Double check that for a few more of the terms, but you will see every single one of these we're timesing by 3. So now we've found the common ratio. So therefore, if we want to find more terms, so for example, if we wanted to find the next 2 terms in this case, the next term would be 40.5 times 3, which is 121.5. And then if we wanted to find the next term, we would have to do 121.5 times by 3, and that's 364.5. And of course, you could carry on this process forever, finding as many terms as you want. So there are several other different types of sequences, the first of which are triangular numbers. It might sound really confusing, however, this model should help you understand what's going on. Basically, triangular numbers are numbers where we can draw sort of a diagram using that number of dots. So for example, we know 10 is a triangular number because I can draw 10 dots in a way that it forms a triangle. The same with 6, the same with 3, the same with 1. I know the 1 doesn't look a lot like a triangle, but we do count it as a triangular number. The rest pretty obviously look like a triangle. So to find the next one, you'll notice this went up by 2, this went up by 3, this went up by 4. So logically, you would say the next term goes up by 5, and yeah, it does. So you could draw another triangle 5 at the base, 4, 3, 2, and then 1. And you can see there's 15 dots there, so that's the next triangular number. So the next one, we added 5 on that, so we'll add 6 for the next one, add 7 for the next one after that, and so on. So the nth term for this is n times n plus 1 over 2. And this defines the sequence of triangular numbers, which you could summarize as 1, 3, 6, 10, 15, 21, and so on. The next one you need to know are square numbers. Now these you should have seen previously. The nth term for this is n squared, and the sequence is just each number squared. So for example, the first term, 1 squared would give you 1. The next term, 2 squared would give you 4. The next term, 3 squared would give you 9, and so on, and you can carry this list on for as long as you want. Next are cubic numbers, very, very similar to square numbers. The nth term is n cubed, and here, again, you just pick the term you want. So if you want the first term, you then cube the number 1, so 1 cubed is 1. The next term would be 2 cubed, which is 8. The next term would be 3 cubed, which is 27. The next term would be 4 cubed, which is 64. The next term would be 5 cubed, which is 125. The next term would be 6 cubed, which is 216. And of course, you can carry this on as much as you want. So for both of these, the list is infinite. You could just keep going, keep adding an extra term. And then finally, we've got the Fibonacci numbers. Now these can be a little bit confusing because it's not immediately obvious. The sequence is as follows. So 1, 1, 2, 3, 5, 8, 13, 21. Here, you might have a look at it and think, well, there's no obvious pattern at all. They're not multiplying by the same thing every time. They're not adding the same thing every time. It looks really confusing. However, the rule is that you add the 2 previous terms together to get the next one. What I mean by that is these two. So the 1 plus the 1 gave us the 2. And then we could do this later on. 5 plus the 8 gave us the 13. So if we wanted to find the next term, we would have to do 13 plus 21. So that term's 34. And of course, we could carry this on again. We could do 34 plus 21 because those are the last 2 terms now. 34 plus 21 would give us 55. So the next term is 55. And of course, you could carry on this sequence for as long as you want on our learning platform. Here, you can answer a series of questions. So say, for example, if I think the next term is 27, and I think the next one is 31, and then I've got an option here to find the nth term of the sequence. So say, for example, if I think is this, I can mark the question. I'll get instant feedback on how I've done, both in a written solution form and a video solution form, where an expert will talk you through exactly how to solve the problem.